Okay, so we're going to talk about, thanks for coming, we're going to talk about AI guardrails. So real quick intro to myself. So I am Bryson Loughmiller. I started at Adobe. I've worked in security for about 10 years now, started the security program over at a company in Lehigh called Podium, and then managed that for a little while and decided I did not like management, and now I'm at Entrata, back in an IC role, doing architecture, kind of anything that needs doing, essentially. So just quick overview of what we're going to talk about today. So going to go over just the kind of some of what Bryce already talked about, the proliferation of LLM integrated applications across all of technology, some of the common vulnerabilities and challenges associated with LLM applications, and then why we need something like guardrails and what guardrails are, AI guardrails. Going to go over a handful of the actual solutions available on the market, and then we're going to go through a walkthrough of how to implement specifically AWS Bedrock Guardrails, and then look at a performance test of a red team scan against Bedrock Guardrails. So if any of this doesn't sound interesting to you, you can leave, I guess, if you want to come back later. So kind of as Bryce was talking about, the mass proliferation of LLM integrated applications across all of technology, right? Everybody's chasing that AI bump on the stock price, and chasing that a little bit maybe more quickly and less thoughtfully than necessary. And so I'm sure everybody has the experience that leadership is trying to push AI into every single aspect of technology, whether or not it makes sense. And as security professionals, that means that we have a bit more of a challenge on our hands to handle this emerging technology. So Gartner, 70% of independent software vendors will have embedded Gen AI capabilities by 2026. 297 billion in spending by 2027, and that 39% of global organizations are currently in the experimentation phase in the adoption curve, which makes, in my opinion, the risk even more prevalent, because in that experimentation phase, people are just kind of doing everything and often throwing caution to the wind, right? What are some of the challenges associated with AI security, and specifically LLM security specifically? Well, AI or LLMs specifically, are stochastic in nature. So as opposed to a predictable output and behavior by an application or software that you usually can expect, LLMs might have a different output every single time. And so depending on the attacks that you're throwing at them, we might get different outputs, and that means difficulty in defending, right? The environment is extremely rapidly evolving. New vulnerabilities are coming out on a regular basis. The models are getting more powerful. The market is shifting, so it's hard to necessarily keep up, which means more security issues are being introduced. You can't really force static rules as effectively on an LLM, and we'll get into this a little bit more later, but it's not as effective as maybe straight if-then logic, for example. And then, yeah, like I said before, a lot of folks are kind of prioritizing time to market over caution. It's more important to have AI in your application than it is to have safe AI at a lot of companies today. And so they just got to get that AI bump, and that's what's most important, and caution gets thrown to the wind. So there's a lot of different specific challenges. OWASP has tried to categorize and classify the top 10 vulnerabilities associated with LLMs in the OWASP Top 10 for LLM applications. If you haven't checked this out, I would highly recommend it. It's a great overview of some of the challenges. We're not going to get into every single one of these, but they basically outline the top 10 things that they see as vulnerabilities associated with LLMs. For guardrails specifically, we're going to talk more about these ones. The others are a little bit more associated with the actual model training and the supply chain of LLMs. These six are more associated with once you actually integrate an LLM into your application and some of the potential challenges. So just really quickly, prompt injection, probably the most common or commonly talked about LLM vulnerability. The idea here is that your system prompt tells your LLM to do a certain thing, and then you have a later prompt that overwrites those initial instructions and redirects the LLM's intention, right? System prompt linkage is another one of the OWASP Top 10 for LLM. The idea here is kind of, these are not the droids you're looking for, prompt injection, and then you extract the entire system prompt, which often can contain sensitive information, if not just how the actual application is functioning or is intending to function, which can be sensitive. Another one is excessive agency. The idea here is essentially when you give a LLM application or an LLM-powered application too many options and too many tools and too much agency. Again, like we talked about, it's hard to necessarily focus it into direct if-then paths, and so you might, if you give it too many options, then you have the possibility of someone taking over one of the options you don't intend. And so giving it excessive agency, another potential issue. So again, we're not going to dive into every single one of those, but just a brief overview of some of those issues. A couple of real-world examples of issues surfacing from LLM-powered applications. So Air Canada, this was last year, they had a customer who was interacting with a chatbot on their website, basically said, I hear you have a bereavement discount for flights, and the chatbot said, we sure do, here's a free flight, and the customer then later on had to pay for that flight and sued Air Canada because the chatbot had told them that the flight should be free. And the courts actually ruled that Air Canada had to fulfill what their chatbot had actually said. And so this was kind of an interesting precedent set, at least in Canada, where you are going to be held accountable for what your AI chatbot promises your customers. So Slack had, another example, Slack had an issue that came out late last year where there was a vulnerability via kind of indirect prompt injection where you could include information from other private channels via Slack AI by including it in a link that you would trick another user to click on. And so multiple different types of vulnerabilities. DeepSeek, when they came out recently, a bunch of researchers were able to go out and expose the entire system prompt because it wasn't protected well enough. And some of that showed indications of OpenAI in the system prompt itself, which was, a big conspiracy that they had used OpenAI themselves or OpenAI data for part of their training. This user found a chatbot on a dealership and convinced the dealership to sell him a Chevy Tahoe for $1, and the chatbot said, hey, okay, we'll do that. And in this case, they did not get held to selling that Tahoe for $1, but the case stands as a potential problem for these types of bots, right? Okay, so how do we actually prevent these types of problems? Today, many people are just adding in their system prompt instructions for the LLM to not do things. And they're basically just, saying, please, bro, don't reveal the secret data. I'm begging you, don't ever reveal the data. My boss will be so mad. And this is kind of the equivalent of giving a 5-year-old a box of matches and telling them, please don't burn down the house, because the LLM is not necessarily always going to do exactly what the system prompt says. And so this is where AI guardrails come into play, right? Where guardrails are essentially your bowling bumpers that try and keep your app within the context of what you want the app to actually be doing, regardless of what the user throws at your application, right? So guardrails kind of get split into, are usually thought of in two camps. So you have your input guardrails and you have your output guardrails. So Input being usually whatever goes into the LLM, oftentimes from a user, or whatever the input is through your LLM flow. And then the output being what comes from the LLM after the fact through your application. And the reason that these two are usually split is there's usually different challenges associated with both. So guardrails themselves are essentially little AI policemen that you throw on the input and on the output to try and determine, is there something malicious, any kind of adversarial prompt coming in on the input side, and is there anything in my output that I don't want, any kind of harmful content, any kind of PII, any kind of behavior that you're not looking for. So, quick little overview of how this might look. Do I have I do, okay. So, kind of like I was mentioning here, you have your application in the center that is talking to some sort of LLM. You have your raw user input that is fed through your input guardrails. Your input guardrails go ahead and look at that, go through all of the assessments, try and determine whether or not there's an attack happening, and then feed either cleaned, masked input through to your application to send to the LLM, or can completely block the activity. So in this example, maybe your user sends a prompt injection, and the input guardrail notices it as a prompt injection, stops the attack, and your application feeds through your default output of, I'm sorry, I can't help you with that, and your application never even receives the malicious input. In the case of maybe output guardrails, let's say that your user asks the system to just list all of the data that you might possibly have, and for whatever reason the input guardrails completely misses and says, yeah, this looks good, and then your application attempts to output Matt Hillary's name as well as his social security number, obviously the legit SSN there, and your output guardrails now have PII checks and say, hey, that's no good. Before it gets sent out to the user itself, you get hit with that stop that says, sorry, I can't help you with that. So this is really effective because many of the attacks on these types of applications are not just going to look like a specific pattern, right? It's going to be base 64 encoded. They're going to ROT13 it. They're going to put spaces between everything. They're going to put it in a different language. They're going to do all sorts of different things to try and trick the LLM into masking the attack or masking the malicious output. And so you can never rely on just simple pattern matching, which is where these AI policemen or whatever are so much more effective. So, caveat, guardrails should never be considered a silver bullet for protecting your LLM application. It is a part of a healthy breakfast here. Like, you should only use guardrails, as with any kind of security solution, as the door, the lock on the door, essentially. You need to have defense in depth. So you really should be also additionally doing careful model selection, carefully choosing what data you actually expose to the LLM, because any data you expose to the LLM right now in this environment is inherently at higher risk than, throwing it in a database or something like that. You need to make sure that you have limited AI autonomy, like we discussed earlier. Make sure that there's always authorized context boundaries. So one thing that I always say to my engineers whenever they're developing a application, I say, okay, for authorized context boundaries, if a user is talking to an LLM, does the data in the context of the LLM match the data that the user has access to? If it ever exceeds that data, that's a problem, because there's a potential for that user to gain access to additional data that they shouldn't receive, right? And then obviously standard rate limiting and input validation. So just as a note, guardrails are great, a part of your defensive strategy, but they should never be considered the silver bullet to stop all problems. Okay, handful of different solutions. So we have some open source solutions, some paid solutions, and this is not a exhaustive list either. This is just a handful that I personally have played with in my exploration. So on the open source side, we have NeMo Guardrails. This is a solution built by NVIDIA, and they have this essentially works directly in the NeMo framework, and so it's highly configurable. It directly integrates with LangChain. It's a little bit difficult in the time that I was using it to just evaluate raw input and output from a different application if you're not directly in the NeMo framework itself, or if you're not using LangChain itself. So it's a little less flexible in that aspect. But if you are already in LangChain or building with NeMo itself, it's a very good option. LLM Guard, just kind of a general library where you can import it, pass input or output through, receive an assessment, and they have a whole bunch of baked-in guards for you. Guardrails AI, it's similar to LLM Guard, integrated as a library. You have to build a guard for each individual thing. They have a whole library of different guards you can use. Pretty powerful as well. Llama Guard, built by Meta, a little bit of a different model. It's a purpose-trained model specifically built as a guardrail, so it's a trained model to try and detect malicious input or unwanted output, and it's a little bit more of a prompt-based guardrail instead of where you just turn on like detect this type of PII. You're writing a prompt about what it is that you do or do not want to see coming into or out of your application. So within paid solutions, we have Bedrock Guardrails. We'll talk a little bit more about those. Guardrails AI Pro, this is that same open source model, but just the enterprise edition, and so they'll host it for you and provide additional metrics. They do a little bit more of a hands-on approach. OpenAI moderation is built in directly into OpenAI, and you can call the moderation API. It focuses primarily on harmful content. It's more of an output guardrail than anything. It doesn't do a lot of like prompt injection or OWASP Top Ten checking on the input. And then Aporia, I haven't played around with this a lot, but it looked like a pretty interesting potential paid solution as well. They do streaming support, so streaming where you have the output of your LLM application actually live printing out to your user. That can be a more difficult solution to Guardrail because you're not getting the entire context immediately, you're just getting chunks. But fully dedicated Guardrail solution with some custom policies and monitoring, so potential good solution. We're going to talk about Bedrock Guardrails though, and this is not because I am sponsored by AWS in any way. This is simply one of my favorite solutions that I have found personally when going through all of these different options that I've explored. The pricing is relatively inexpensive. So in December, they actually just cut all of the Guardrails prices by 85%. So it's a lot cheaper than it was previously. Additionally, they've been rapidly developing it, and it's been getting a lot better than it was even 6 months ago. Yeah, basic example here, and you can go look at the pricing calculator if you want. But if you have a chatbot app that's doing 10,000 inputs per day, you're doing input protections to look for prompt injection and that type of thing, you're going to pay about $1.50 a day. So it's not wildly expensive, but at certain scales, it might not be feasible. You know, just depends on what your use case is. Okay, so how do we get into the implementation? As with any Guardrails app or any Guardrails implementation, the first step is to actually understand your application. If you just try and dive in and you're hoping to just click a button and your app is going to be protected, you're probably going to fail either with false positives on your detections and your app breaking, or you're going to miss actual malicious content that you want to block, right? So make sure you understand your application. What are your outputs? What is your untrusted input and content? What do you want to allow to reach your app? Maybe you don't care if the user is cussing out your chatbot, and you don't care about blocking profanity coming in, but you do care about your chatbot cussing out your user, potentially, probably. So those are the types of things you want to make sure you understand before you step in to configure the actual Guardrails. And then I find it handy to set up separate input and separate output guardrails because you may have different needs on both sides. So now we're going to see if my VPN has decided to stop having a bad day. Give me a sec, sorry. And if I can, okay, I think we're actually set. Okay, so let's jump into Bedrock itself. If you're unfamiliar with AWS Bedrock, this is AWS's Gen AI solution. So you can hop in and you can invoke models directly through Bedrock itself. They have a whole bunch of different agent solutions, the ability to run Anthropic models, OpenAI models, their own foundation models, open source models, all sorts of stuff directly through Bedrock itself. Pretty powerful. But they also have our guardrails here. So to set one of these up, you just go into Bedrock, go to Guardrails, and then create your guardrail. So let's just create an input guardrail, give it a name. Let's see, is that too small? There we go. Give it a default message that you want to send if the content is blocked, and then you hop into the actual configuration of the guardrails themselves. So, for example, we can configure protections against harmful categories, and these are essentially just basic sliders for hate, insult, sexual content, violence, misconduct, all these different things that you may or may not want to block coming in and out of your application, how strong you want those to be. Currently, it primarily functions on text, again, LLMs, but they are actually previewing image content as well, if that's something that you want to protect within your app. Prompt attacks, probably one of the most valuable things you can do on your input guardrails, because that's going to be looking for your jailbreaking attempts, your prompt injection, just all of these types of actual attacks against your application. It's a little bit black box in the sense that all you have here is a little slider to just control that, but I have found it to be quite effective, even just as a black box solution. So let's say we only care about the prompt attacks for our input one. Keep going here. You can add denied topics. So if you have something where your application, let's say you never want your application to talk about the geopolitical state of the United States of America or something. And you basically just give it a prompt of the type of content you never want your app talking about. It will review the content going in or out and make sure that it does not look like that. So profanity filter, again, if you care about your app cussing at your customers, probably something you want to get rid of. And then if you have custom words and phrases specifically that you, for whatever reason, want to never have your app receive or say itself, if for some reason you really, really never wanted to say the word snowboard, you can do, if you're just a snowboard hater, you can make sure that your app never says that. And these checks are actually free as well. So these are just base pattern matching, and these are free in Bedrock Guardrails. Sensitive information filters, they have a whole bunch of pre-baked PII types. So if you come in here, they already have everything built out for AWS access keys, passport number, driver's license, IPv4, credit card. So let's just say throw a credit card in there, and if it comes through, you can either block or mask. Let's mask that, and then you can add custom regex patterns. And I am not going to write a regex live right now. So another really powerful thing that Bedrock has is grounding and relevance checks. So grounding and relevance, grounding allows you to pass it a reference material. And so let's say that your application is a property management chatbot of some sort, and it has a reference of a bunch of different properties that it has context of. you can pass it that reference material, and it will check to see whether the output is accurate according to the original reference material or not. So grounding checks for factual relevance to the original reference content. The relevance check makes sure that it is not jumping off and, I don't know, talking about SeaWorld or something out of nowhere instead of your original reference material. So this can be a really powerful, again, guardrail to keep your application discussing what it's supposed to be discussing. And then we create this, and that's it. And now you've got all the information you need to go ahead and start using this. So let's see here. So if we want an example, I think we said the politics here. This may or may not work. No, I didn't set up the actual models themselves. It's fine. We don't need to do that here. Okay, so that's how to actually set up and configure it in the console. Pretty easy, relatively easy, and once you're done, you can go back and set up drafts of each one so that as you tweak them, if you have false positives where content is being blocked that you don't want blocked, you can go in and adjust those sliders, make new drafts, new versions, and run your content through that. So, okay, we already talked about all of those types of assessments that it can do. So now that we have the actual guardrail configured in AWS, how do we actually integrate it into your application? Well, if your app is one of these types of things where it's just using Bedrock on the back end, it's just Bedrock in disguise, as so many, or OpenAI in disguise. With Bedrock, they actually have this baked into all of their invoke model and other calls. So if you're using their agent approach, if you're using invoke model to run your LLMs through Bedrock itself, you can actually just use guardrails directly through those calls. And so if you're already using Bedrock itself, this makes it super, super, super easy. But a lot of applications are not doing that, right? A lot of applications are just hitting the OpenAI API directly, or hitting Anthropic API directly, or running a local model even, those types of things, and that is not a viable option. So they have a much more flexible method through the ApplyGuardrail API. And the ApplyGuardrail API is super simple. All it does is ask you whether or not this is input or output content, and then provide the content. And then it'll run an assessment on it and return you the information. So with that methodology, you can integrate that into any application you want, which is really nice. So you don't have to be baked directly into Bedrock. So they also have this baked into the SDK, the Boto 3 SDK in Python, if we want to run it through that. They have it in the CLI, all these different methods. So it doesn't even have to be like a direct REST API call even. Once you do that, it's a little small, you receive a response object that basically tells you these are all the assessments that Guardrails ran. This is what it discovered. This is what was masked. This is the latency that was added, which can be extremely valuable because a lot of the times when working with engineering and applying guardrails, your engineering teams are going to be worried, well, how much is this going to slow it down for the customer, for the client? And it will actually give you the exact metrics of how much latency was added per guardrail check. Okay, so back to our chatbot example. Now that we have Bedrock specifically, user sends input into your application. Your application sends that data over via the ApplyGuardrails API. You get that response back into your application, and then your app decides, okay, I now have the information about the assessments. What is the application itself going to do with that? If it is clean, it can decide to pass it over to the LLM model. And then similarly, you take the output from the LLM and you run it through your output guardrail, through ApplyGuardrail. And again, based on the app logic, you just decide whether or not you're going to pass a default message back to the user, you're going to pass a masked message back to the user, whatever the proper next step is. Another nice thing you can do is, because you get so much data out of the response object, you can log everything that's happening if you want to an external system so that you can get metrics about what your guardrails are doing. What's that latency looking like? What's the cost? What type of malicious prompts are coming into my environment? And you can build nice little dashboards if you want. There's a little Splunk dashboard I built that just kind of goes through and shows the actions happening where guardrails intervened, whether or not it was input and output, the number of interventions, time, or interventions over time, the actual latency, just tons of observability metrics so that you can go back and then later tune your environment. So, okay, how does this actually perform though? So it's good and dandy that this exists, but how does it actually perform against a legit attack, right? So with red teaming, let's see, really brief touch into something called rainbow teaming. There was a paper written about a tactic that they referred to as rainbow teaming. The idea behind rainbow teaming, and without going super deep into red teaming against an AI application is trying to send adversarial inputs to get adversarial outputs, some type of attack that you want. The difficulty with that is that doing red teaming manually can be very time consuming because there are so many different potential methodologies to actually attack an application. If you're going to B-Sides next month, I'm giving a talk on red teaming as well, so we can get into that. But rainbow teaming essentially just is a matrix of the types of adversarial prompts that you want to elicit from the model, and then another conversion of attack style. And so there's so many different types of attacks. The multilingual, you can send it in Portuguese instead. You can send it backwards. You can send it base 64 encoded. You can tell it you're an admin and all these different things. And so essentially rainbow teaming uses an automated method to have an LLM transform your attack by each one of these different types of adversarial inputs. So it's a really good way to generate thousands of adversarial inputs, attack an application, and see how it performs. One of my favorite systems for red teaming, and specifically this type of rainbow teaming, is a tool called PromptFoo. PromptFoo built a red teaming framework that's still kind of in progress, but it's pretty powerful. It's an open source tool, and you can set this up to set up attacks and tests against your applications. Again, B-Sides, shout out, that's what I'm gonna go over in a month. So. When you run a PromptFoo assessment, you kind of get an output of the types of vulnerabilities that are happening. So for testing here, I built a little basic AI chatbot that just receives input, passes it to an LLM, and returns the output. Extremely simple with a basic system prompt that says, don't do malicious things, basically. This instance right here is where I had no guardrails on the AI application itself, launched the red teaming attack against it, and you can see it was successful in some cases in not returning malicious content, but it often, 43 failed probes, 51 failed probes, 67 failed probes. It was failing pretty frequently. The application was failing pretty frequently. Whereas on the other hand, and this is actually the metrics from the red team attack that I launched. So it launched 2,000-ish inputs, malicious adversarial inputs at my application. Only cost 40 cents in guardrails. And then you can kind of see, this is way too small, but down here you can see all of the different types of malicious activity it was either detecting coming out of the application or in. And it's very fun to go through the inputs because it gets real unhinged real fast in terms of what it's asking the model to do, and then the outputs are also unhinged, and I am not going to present any of the content of that because I don't want to get canceled, even though the LLM was the one doing it. But so in this case, where the guardrail was actually protecting it, you can see just how effective the Bedrock guardrails were in comparison. It actually was 100% successful. So every single malicious input and every single malicious output was stopped by a pretty basic configuration of Bedrock guardrails against this red teaming attempt. So pretty dang effective in general. Again, not always going to catch and stop everything, but a very good first gate against these types of attacks. Okay, so that's essentially the meat of the presentation. Again, some quick caveats, like I said, not every single use case is going to need a guardrail. Make sure that you understand your application, its use cases, what's coming into it, what is expected to go out of it. It may not, I use the example of a chatbot often here because it's one of the simplest examples, but there are many, many, many different types of use cases with LLM integrated applications. And so just understand what your use case is and whether or not a guardrail makes sense, because it may not. Guardrails are only a part of the solution. Again, careful architecture, careful, thoughtful development, not being stupid are very key and core parts to developing a secure AI application. And then again, this landscape is extremely rapidly changing. In a year, this entire presentation is probably going to be wildly outdated, right? Because this is just moving so quickly. And so this is a potential good solution, but always keep an eye on everything that's the new emerging tech. And yeah, got to try and keep up. So that's all I got. Any questions? Yeah.
Fun. How much money can I make you rack up by continuing to poke that with prompts despite that? Is that just a rate limiting model that they implement, or is it, you know?
So Bedrock, Bedrock Guardrails doesn't have a rate limiting function built in directly, but I think that any kind of, well, I was going to say unauthorized or unauthenticated, but any kind of internet exposed chat application or LLM based application needs to have rate limiting on it, because even if it's guardrails or just whatever model you're hitting, the cost bloat is a major, it's actually one of the OWASP Top 10 LLM is excessive resource usage. So no, guardrails does not have baked in rate limiting, but it's just something you need to implement. Yeah, exactly, yeah. Any other questions?